Today we are be hosting an event with collaboration with HVR. I'm Kai Sing, the moderator for today. And yeah, we will be talking about real-time data delivery, a lot of cloud, as well as some cloud technologies. And I'm very happy to kind of have three guests with us today. And I'll be introducing them in a short while. Sorry about the background. I have a young child at home, so you're trying. She's missing her daddy, so we're trying to sort out. My wife is trying to take care of her. So today the topic is about real-time data delivery. So for myself, I work in the finance sector. So if you think about the finance sector, we have lots of data. Think about all the movies you've seen about stock traders, brokers shouting at the screen, and basically all this financial data in the world is powering in real time our entire financial structure across the planet. But finance is really just one very small, maybe big, but one very subsection of the real-time data delivery systems in the world. There are many examples. And today I'd like to introduce some of our panelists to kind of share with us their experience with dealing with real-time data. So first up, we have Andrew. Andrew, would you like to introduce yourself? Andrew is a director at Google, and definitely I think Google is a big player in the cloud and real-time systems. So on to you, Andrew.
Yeah, thank you, Guy. Thank you for the introduction, and thank you for having me here today, and welcome everybody. So my name is Andrew Saltis. I am the director of the Analytics and AI and ML practices at Google Cloud for Asia Pacific. And this topic is near and dear to my heart. I've spent probably most of the last dozen years thinking about, dreaming about, and working on streaming systems in real time. And so as part of my role within Google, that is an essential part of it. And when you look across our platform, it's everything to do with data and AI. So fascinating topic, and looking forward to participating here today.
Thank you, Andrew. Next up, we have Jeff from Snowflake. Jeff, would you like to take the stage?
Thank you so much for that introduction. My name is Jeff Soon. I've been based in Singapore for the last 7 years, and I'm the managing director for Snowflake South Asia. So it's really exciting to have the opportunity to work with many of our customers in terms of developing real-time systems for them. Thanks a lot, Kai Sing.
Thank you. And finally, we have Mark from HVR. Mark, would you like to introduce yourself?
Absolutely, thank you. So my name is Mark Vanderwiel. I'm CTO at HVR. At HVR, we work on real-time data replication systems. And throughout my career, I've worked for real-time data replication providers as well as database companies with a focus on analytics. So today's topic is really near and dear to my heart. And I really enjoy being here today with the other panelists to discuss real-time analytics. Thank you.
Thank you. So I think let's start off thinking about real-time, right? This is the major topic today. What exactly is real-time, and what are some applications we have when we think about real-time? What are some examples you have seen? Maybe Andrew, let's start with you. What are some of the examples you have seen, and what's real-time to you?
Yeah, so I think the first thing is, what is real time to me? And it really comes down to real time's in the eyes of the beholder, if you will. Right? Depending upon where you work and what you do, you may be processing data that takes weeks, that real time to you means a day. Right? Or you may be doing things where real time means seconds. Or you may be in the hardware space where real time means microseconds, and there's a life that depends on it. So it really is somewhere along that spectrum. It depends on the business. When I look at examples of it, it's everything from you're wanting updates as to where your grab car is, where your order is. You're expecting to see where the car is as it pulls up. That's real time happening in front of you. You're expecting when you swipe a credit card at tap that if there's fraud, you're notified immediately. That's real time. You expect all sorts of these things that we take for granted as consumers. From the business, it's the same thing, right? Of how do you start to make these decisions in near real time? I use near real time because we work in the software world, so even a second ago is really history, right? And some people say that real time only happens if it's hardware where life's on the line. So the examples are all around us. And I think this is a fascinating time to understand, how do you apply this to your business problems?
Definitely makes sense. Yeah, even like in the finance world, real time can be something like if you're trading, you want it to be like instantaneous, you want to have a pipe straight to the exchange. That's like crazy expensive real time, but that's what it takes to kind of beat the market. So it's kind of case study based. I think it's a good time. How about Jeff? What do you think about this topic about real time and what use cases you have seen in the market?
Sure. I think real time is really providing people with data at a quick enough rate that they can actually make a meaningful decision. I think sometimes with the technology, we get very obsessed on SLAs and that kind of thing. It's really about providing people with the right data so they can make a decision to make a difference. And I guess from our perspective, we're really seeing three industries where real-time analytics has really taken off. The first one is video gaming, and specifically free to play. So as you know, with that business model, you provide access to a game at no charge, but what you're trying to do is monetize it via microtransactions. So the need there to be able to provide really timely offers to gamers has been quite a change, and quite reliant on real-time data. The second opportunity is, I think in Asia, we've seen the advent of super applications being taken to market, and the ability once again then to be able to provide a meaningful offer or a meaningful suggestion in that near real time is really impactful, right? So if I've booked myself a share ride, if before I get to the destination, I can receive some meaningful offers, that has met that real time objective. And I think the third thing, given your background in financial services, has been the complete transformation, I think, of your traditional broking applications, right? With the advent of Reddit, with the advent of, all these different people providing, information that can dramatically change the market in minutes. It's really been enjoying to see some of the latest trading applications include Twitter feeds, discussion groups, level 2 data to make it so much more enticing to actually invest.
Yeah, I think all this unstructured and maybe we are saying this kind of alternative data sources, right, is only possible because of all these new capabilities, new technologies that Snowflake and even HVR brings to the table, Google brings to the table, which brings us to Mark. Maybe you want to share a bit more about HVR as well as your role as a CTO at HVR. What do you see as real time and what do you see in this entire ecosystem?
Yeah, so I'm taking a bit of the perspective of Andrew and Jeff in this conversation, in that real time is indeed in the eyes of the beholder. And where we play a lot in the case of HVR is in high volume complex systems. We often see organizations consolidate data out of multiple systems, but really in organizations where there's really high volume and or many systems involved, and the use cases are really across industry. So I'd say if you think about your own industry, like what business you play in as an organization, there's got to be use cases out there. Like, for example, we see lots of use cases in manufacturing where there is lots of machine generated data these days that's going to be very helpful in identifying preventative maintenance, as an example. And of course, in order to do preventive maintenance on complex machinery, you have to get some insight into inventories, into the manufacturing chain, maybe into the supply chain that's feeding the plants, in order to get the right data at the right time, get the parts built to service the equipment, but then also to have a technician there at the right time in place in order to help the organization who is using your equipment as a manufacturer to be successful in their in their business, right? So, like, for example, if you think about locomotives as complex machinery, if you can help your customers operate their locomotives at a slightly higher average speed over the lifetime of the locomotive, that is like tens, if not hundreds of millions of dollars of additional revenue, if not profit, that an organization can generate. And these are valuable examples. So we see these in manufacturing, we see it in consumer products. Obviously, you're well aware of the financial industry and how it plays there. We see it in marketing, demand generation, we see it in sales. There's lots of use cases. Now, you ask about my role as a CTO at HVR. What really gets me excited is those different use cases, is to see how organizations can utilize the technology in order to be more efficient with their data, right? Like we we talk about enabling organizations getting the maximum value, the maximum potential out of their data. That's really what we're all about, and that's what excites me most in my role.
Thank you, Mark. I think you've touched on quite a few points. I think all of us have kind of a different lens on what real time as well as how it applies to the different use cases. I think back to you, Andrew, how about we go a bit deeper? What are the components do you think that make up a real-time system? And at the same time, what are some of the challenges you see when deploying such real-time systems in the real world?
Yeah, no, that's great. And I think you hit on it, right? If we're talking about these broad systems, I think, Jeff talked about one side of it, making sure that you have data as a human at the right time to make a decision. And Mark did as well about locomotive and doing predictive. But the other side of the manufacturing is you need to react now and shut down a line immediately before you cause millions of dollars of damage. All right. So there's the side of the real time where it's a human in the loop and you were making the decisions. There's the other side where it's a machine making the decisions and you need to be able to, act immediately. So when you look at how these things get deployed, it really is across that spectrum, right? Of how do you have a system where it's ingesting data, whether it is data coming off of a machine or it's sensor data. How do you ingest that? How do you bring it back? How do you do the predictive stuff? So now you have, storing that data in some sort of warehouse. How do you do the learning on top of it? How do you enable that and do prediction from the business? How do you get that model then, if it is predictive, that's trained in mass? How do you get that back to the edge? So if we play on kind of what Mark was talking about with like predictive or doing things, we see customers doing stuff with like visual inspection of all sorts of things. Right? I want to inspect that my phone that's being manufactured is not defective, or I want to inspect that cuts of meat were right, or bottles of shampoo are sealed correctly. So that visual inspection has to happen right there on the line, which takes machine learning model to be able to do that. But you need a lot of data to train the model. So you have to get all these images back to some data store, ideally a cloud in our view, that you then could train this, learn from it, and then deploy that model back out so you can make decisions. So there's both sides of that, of having it where you have the tooling to be able to do this across that entire spectrum, from that factory floor all the way back to the business users being able to use it, and inside of a Google Sheet or a spreadsheet where you can now interrogate the data, you can do predicting. When you look at the skill sets and the tools, like I said, I've been around these systems since the open source stuff and before the open source streaming systems came about, for like a dozen years. It's still an amazement. It's still a hard thing for people to get around. And it's still a lack of skills of being able to do it. So one of the things we see is how do you provide that and really kind of grow the ecosystem? And when you look across the things that Google has done and kind of our view of this is how do you democratize access to AI? And democratize access to analytics. So how do you start to do things that enable a business user that's not a data scientist? No offense to you, Kai, but there's so many data scientists, there's a lot of business analysts. So how do we make it where you and your peers spend most of your time really working on hard problems, not lots of time cleaning, gathering data, and not answering questions that an analyst could do if they had SQL interface to an ML system? And they could train and learn that way. So we look at it as making it so it's not how do you raise the skills of people and train people, but how do you bring the technology closer to where the masses are? And all the way up where we have integration of data Q&A inside of Google Sheets. So now I can ask natural language questions of data that's using an ML and AI platform behind the scenes in the warehouse without me having any idea. So I think from a deployment, you have to have the systems that help you make sense of this easily and up to speed, whether that's on the edge in the factory floor, all the way back to the enterprise. And then you have to have the tooling to enable more business users to be able to do it, and really raising that bar as to who can interact with data.
Sense. Thank you, Andrew. So Jeff, same question to you. What are the key components in a real-time systems, and what are some of the challenges you have seen when people try to deploy such systems?
Yeah, look, I'll start with the challenges. I think sometimes, and we still see examples of there's not the recognition that this is both a business as well as a technology platform. So we see many technology teams with the best of intentions, build these bleeding edge systems, yet they're not necessarily aligned with the actual business problem that you're trying to solve. Are we trying to solve, as Mark brought up, a predictive maintenance problem? Are we trying to solve an upsell, cross-sell problem? Are we actually trying to create a new business model that we can disrupt the market with? So I think the first thing is we need to work out some sort of framework where we can actually capture our expectations of the data, which source systems we're tapping, and which consumers of that data, what the data actually consumers will be, whether it's a person or some sort of automated process. So I think there's a need to both do the technology as well as the business. From the technology perspective, I think the biggest challenge is, and Snowflake, like Google, take a cloud-first perspective, but the reality is that we have lots of source systems out there that are still built on antiquated technology. And that's where our partnership with organizations like HVR have come into place, because you're only as fast as the slowest data pipeline within this ecosystem. So I think there's the need to be conscious of how you're constructing these pipelines, what technologies to use, but more importantly, what problems are you actually going to solve once we've put in place this architecture or this solution.
Yeah, Jeff, I think I really like the point that you're only as fast as the slowest man, slowest pipeline in this case, right? That definitely makes a lot of sense. Back to you, Mark. So I think HVR as like kind of the pipeline that help to settle this slowest man syndrome. What to you what are some of the key components in building a real-time systems, and what challenges you have seen so far in the market?
Yes, thank you for that question. And of course, my view on this is somewhat biased because we work on real-time systems all day, every day. But one of the biggest challenges, like Jeff, I'm going to start with a challenge. One of the big challenges is that there is no downtime in systems anymore, right? With the advent of the internet and everybody selling online and operating their businesses or organizations online, there is no real downtime in systems anymore. And with that, like when there might have been a convenient window to perform a data load, that is no longer there. And that's where technology components such as HVR come in, where we enable log-based change data capture on those systems to not only capture the changes as they happen, but arguably more importantly is to capture those changes with no impact on the transactions as they happen, and absolute minimal impact on the systems as they process these transactions. We see massive volumes in the world. We see massive volumes in Asia, of course, because the consumer industry is so large in Asia. And that's really where a technology such as HVR, where you provide log-based change data capture with minimal impact on these source systems, allows data to be moved into more of the analytical environment in Google Cloud, into Snowflake. And then, from a technology perspective, a secondary challenge is then to manage to just keep up with the sheer aggregate volume of change data, right? Like when let's say 2 decades ago, a system of a terabyte was large in size. Nowadays, we see organizations generate a terabyte of changes on a single database in less than a day. And we have to take the data and move it into a Snowflake or into a Google Cloud. And how can you do that efficiently in a way that even though the system might still reside on premises, you take it into the cloud, there's a terabyte of data, like it needs to pass over a network. And you want to do this as close to real time as possible. So some of the biggest challenges are within that spectrum from our perspective. But then, of course, there's additional sources that get added to this system, like social media feeds. There's IoT data. There's arguably even more data getting generated, but on the edge in the cloud already, that also needs to be fed into those systems. It's dealing with that volume. And the cloud is really a perfect ground for that, with an on-demand scalability that has, wide limits, let's say, if there are any limits.
Yeah, thank you, Mark. That makes a lot of sense. So I think it's a good kind of transition into our second topic. I think we want to, all this things we know about the baseline real-time systems, but how do we leverage all this technology that you guys bring from your companies to really kind of integrate it together and really get things going, right? I think, Andrew, you already touched on a few touch points about how Google has all these various tools. Maybe you want to elaborate a bit more that since Google has this massive cloud platform, all this expertise in deploying AI ML solutions, how can companies like small companies or even like MNCs leverage on the services and tools provided by Google? What are your opinion on this?
Yeah, it's great. So, as I had said, that obviously GCP, just like any cloud provider, is a massive surface area. Right? But if you zoom in on the analytics and the AI, one of the things that differentiating approaches have taken is how do you have a complete integrated approach, and how do you provide access to that for the masses? And it used to be not too long ago that people would joke of two people in a garage could build a business in a weekend because of the advent of cloud. And really believe that now you can have that same thing happen, that two people can build an AI business in a weekend with some of the tooling. And only a matter of time before maybe there's a single person that creates the next unicorn. And so our view of this is really, how do you have it completely integrated? So as an example, in the finance space, we recently published, a pattern that was done with a partner of ours, Cosmos in Australia, on predicting real-time anomalies in Forex data. So they built this entire pipeline of ingesting Forex data, running it through, in our data flow in the streaming processing, of running it through and doing anomaly detection with a time series library that we have that could go ahead and can look at relative strength indicators out of the box. So they're able to do that, react to anomalies, decide buy or sell, stream that data then back into our warehouse in the BigQuery to then do further analysis of it. And with the AI pipeline, have a completely built pipeline to continuously retrain and analyze data. So that was built with them writing close to no code. It's stitching some stuff together because it's all integrated. So it's an entire approach of saying, yes, we have an AI platform. Yes, we have an analytics platform. For some people that really want to go, into the the bits, if you will, of the data science aspect, and really want to go deep, we have everything there. But then across that, it's integrated completely all through the analytics stack. So if you're streaming data, you could take advantage of ML models right there. You could do learning right there. You could do training. If you're using stuff in the warehouse, there's almost a dozen models provided out of the box for you to do complete training and inference with just a SQL interface. So you don't need to do anything except start loading data and query. All right, so you could be streaming in Forex data if you wanted to into a warehouse and start doing time series anomaly detection with just SQL. All right, so there's all these things, and our approach is really then allow that where it's the tools that the data scientists could use to go as low as they want. They could do stuff with GPUs and TPUs and whatever your heart's content, all the way through how do I not have to worry about that? And I can leverage that same AI technology through the analytics. So in our view, our approach to it is really, it's an integrated platform. And to touch on like what Jeff was talking about the business problem, we look at that same way, right? It's how do you solve this business problem and not get held up by what's the technology, right? So like in your world, like data science, like the problems of how do you deploy models? When you look at like 1 out of every 5 projects actually makes it to production. How do you have a robust ML ops environment where you don't have to worry about that? So it's really, how do you have a managed environment that we could take away the burden of the operations? How do we have a complete integrated perspective? And then how do you make it so you think about it from the business first and it's all integrated? You don't have to do all that work of gluing things together on your own, which takes up the time and takes away from you adding to the bottom line of your enterprise.
Makes a lot of sense. Thank you, Andrew. So on to Jeff. I think Snowflakes, after your IPO, you have been doing really well. What is so unique about Snowflake's cloud-based system, data delivery platform? How can companies, big and small companies, kind of build their real-time and delivery solutions on Snowflake?
Yeah, look, I think there's 2 very unique things about Snowflake, and it kind of mirrors the evolution of our organization. So we're 9 years old, and I would say we probably spent the first 5 years of our existence really lowering the barriers from a technology perspective. So we wanted to create a solution that was multi-cloud, and you just abstract all the infrastructure away from it. You simply need to focus on your analytics. We also made it really easy for our customers to back up their data to ensure that it was safe and secure by providing a fully managed service. So that was the first thing we wanted to do. And, I think we've done a reasonable job at addressing that challenge. I think the next challenge that we all need to solve is really how we can democratize access to data, not only within an individual organization, but within an ecosystem of companies or an ecosystem of data. Because it's not just about now breaking down the silos between data trapped in a marketing cloud or data trapped in an ERP or CRM cloud, data trapped within your on-premise IaaS solutions or infrastructure. It's now, how can I take my organization data and start to enhance it and mesh it and collaborate with, number one, my second-party partners. So if I'm a financial institution, I may need to trade data with bureau services. I may need to exchange data with credit card providers. I may need to exchange data with regulatory providers. How can I actually take away the friction from that? And I think the final part, especially when you look at the massive disruption that we've encountered due to the COVID pandemic, how can I start to leverage, trusted third-party data sources such as weather data, such as macroeconomic data, such as audience management data, and bring all these different types of data, my first, second, and third-party data together into a platform where we can start to do some meaningful analytics, in a platform where we can do, as Andrew said, run meaningful ML and AI models, because it's not about just using the data that you have within your organization. It's about being able to leverage partner data. And I think, especially in the Asian region, we're so lucky that we're almost at the epicenter of all these really exciting digital banks being launched. And almost all of these initiatives are joint ventures. They're joint ventures between telcos, they're joint ventures between, retail conglomerates, technology companies, and more, I think, really data sharing is going to be one of the key requirements to really optimize how businesses are run moving forward.
Thank you, Jeff. I think it makes a lot of sense. Definitely, you see a lot of new, even like unicorns and new startups and joint ventures, like you said, kind of leveraging on these various cloud tools to kind of scale up the system. So I'd like to paste a case study to everyone. So on to you, Mark. On HVR's website, right, I've shared the link for the case study of HVR. We have a real-time integration of HVR, Snowflake on GCP, just kind of like we're tying all the technologies we have talked about so far. Will you share with us some of the key features of HVR and the role HVR plays in this real-time integration across these three different components?
Absolutely. So from HR's perspective, the technology runs in a distributed setup. So we still see a lot of organizations who have some on-premises deployments of legacy technologies, traditional relational database technologies, high volume systems running in an on-prem environment. And we need to unlock that data, whether it's SAP ERP data or other ERP or the supply chain management software. You name it, there's industry-specific applications. That's where we start with a lightweight agent in order to, as most efficiently possible, capture the change data, densely compress it, encrypt the data so that it can securely move into a Google Cloud. Now, there is a control environment. We refer to this as a hub. That hub nowadays often lives in a Google Cloud platform because it's so much easier for organizations to just allocate resources in a cloud environment relative to an on-prem environment. So that's where the choice often lays. And then there is a scalable delivery for that system, again, through a lightweight agent into Snowflake. And that's just to make sure that we can get the performance, get the real-time aspect in the eyes of the beholder, like we said at the beginning of this discussion, where some organizations will say, well, if the data is there within an hour of originating on the source system, it's plenty of real time, and we can service our business with that kind of level of real timeliness. Whereas other companies or other organizations, like for example in the United States, the 1-800-Flowers, which is kind of like a global brand, the way I look at it, an organization that's all about gifting, like they're really into real time, and they have a number of different gifting platforms where they really want to optimize the analytics around it, and they want to go down to as close to real time as possible. So with latency of well under a minute in most cases, the data originating in the source systems and getting delivered into the destination systems. Now, into Snowflake on the Google Cloud Platform, we do leverage the best practices to be able to update Snowflake as close to real time as possible. So we leverage the Google Cloud Storage along the way for incremental staging. I mentioned some of the large volumes that we're dealing with these days before, and Snowflake just was not built for online transaction processing. So you want to create micro batches. And to do that most efficiently into Snowflake running on GCP, we leverage the GCS, copy the data into Snowflake, and then run micro batches using merge statements and transient tables in Snowflake to essentially get a copy of that data as up to date as possible in as close to real time as makes sense to the organization. So now, I mentioned this before, but along the way, when the HAR technology manages the data is compressed, it is encrypted using state-of-the-art TLS 1.3 encryption. So security, of course, it's important to Snowflake, important to Google, it's important to HAR, it's important to all organizations, right? So we keep it there, but with the compression, we make optimum use of the resources that are available, and notably network resources, especially in hybrid clouds or in an on-prem cloud environment is really key. So all of these, the technology leverages all these best practices in order to get an environment up and running as to service or to serve the business as good as possible.
Thank you, Mark. I think now we have a very clear understanding of all these components and all these pieces of the puzzle, right? I think it's time to move on also to our last topic. It's really to focus on Asia. I think all three of our panelists talk about Asia today. It's quite different from, let's say, a decade ago. Now we see the growth of China. We see the growth of even Southeast Asia. How many unicorns are coming up? Gojek, Gojek merger. There's a lot of exciting news that's all coming up. Grab is doing a SPAC, so on and so forth. But what are some of the unique challenges in Asia? When we say we do business in Asia, every country is so different. China, Indonesia, Singapore, even within Indonesia, Jakarta versus a fishing village versus tier 2 cities. It's all very different in terms of like the target audience, in terms of business. So maybe let's start with Andrew again. What are some of the opportunities and challenges uniquely Asia that you see when you try to deliver solutions, real-time solutions in this part of the world?
Yeah, so I think that's a great question. You're right. I mean, it's so disparate, and it's so many different use cases and so many different types of capabilities. I think one of the things that we often see is definitely the distance. And you see things of, say, it's in Western Australia and it's mining. Now you have mines that may not really have connectivity. So how do you deal with that and have solutions and be able to get data back to where it's going? How do you deal with things where, obviously, depending upon the AI solution, we do a lot with speech to text, text to speech, so language becomes something, right? Of how do you deal with all the different languages when you're building models? One thing that obviously is top of mind everywhere is data residency. You know, almost every country now has data sovereignty laws of data can't leave, you know, a country. So how do you make sure that all those services are available? And then really it's such a widespread of skills, right? From some of the, you know, as you said, like the unicorns in Southeast Asia to some of the larger companies in North Asia that really are pushing the boundaries of AI and really doing that need those high-end capabilities and those tools and services, to the complete opposite side of the spectrum of those that they don't have a data science team. And they're not going to have a data science team, but as you know, Jefferson, like they still want to make decisions and have access to it. So how do you provide that democratization where they could get access? So I think that the challenge is really, it's such an amazing environment to work across all the skill sets and make sure that you could close the gaps across them. Making sure, the things that Jeff talked about as far as like Snowflake providing this managed service. How do you have that type of great experience, right? That you can leverage that where it's not just for those that are a small business that doesn't have an IT arm, but the larger business that does, where they could enhance their operational capabilities. All right, so I think it's really the challenges are language, distance, keeping data and processing data in region, and then dealing with that, and really it ends up being like in country. So I'd say language, locality of data, and then services that cover the entire spectrum of skills. So you could work with the unicorns that are trying to push the boundaries and meet their needs, all the way through, the fisherman that wants to put online the fact that he has a new stock that's for sale and react to things in real time. So I think it's a fascinating environment of the use cases and the distribution of skills, of really how do we help everyone make that leap.
Great. I think that's really, really nice, insightful answer. Thank you, Andrew. So Jeff, same question. What's the unique challenge in Asia, and what are opportunities as well you see in this region?
So firstly, I have to say, and we're very, very thankful to our cloud partners such as Google, etc., that they've really set the infrastructure foundation. Like if we went back 15 years ago, it would be almost impossible to have this rich, vibrant ecosystem we had. If to do anything, you needed to go deploy servers in the data center. So I think, Google and the rest of the hyperscalers have done an amazing job, and they continue to do so with, deploying in more and more regions of providing, I guess, that foundation. The challenge that we have, and I think some of our partners, is we need to take very much a channel approach to get that reach, because there's so many different cultures, there's so many different languages, there's so many different states of maturity. We, and I think many of our partner ecosystem, many of our peers are dependent on having rich, vibrant SIs and partners that can actually help take our technology to the end customer. And, building that, I think, is part of the skill of being successful in this region. And the final thing, if you take it up to the data layer, this isn't like the US where, pretty much Equifax and FICO have credit ratings on, all 300 million American citizens. In Asia, you've got, 15, 16 different countries, all with different data providers, all with different bureau services. And to be honest, in some countries with far less, credible census data than you would have in a more developed country such as the US, Europe, or Australia. So I think, these challenges with actually getting meaningful localized data sets sometimes impact, but I also think it's also a great opportunity. I mean, we've seen lots of startups differentiate themselves on technology. I can't help but imagine that the next 5 years, we're going to see a lot of wealth created in companies that can provide rich, meaningful, localized data.
Yeah, definitely. I think it's very exciting times in Asia as well. So moving on to Mark. So what have you seen in Asia that kind of strikes your attention in terms of opportunities and challenges?
Yeah, so there's going to be overlap between what Jeff mentioned and what Andrew said. So, but one aspect that I definitely see is volume, right? Like the Asian market is huge. If you just take China with the number of consumers and just the essentially the consumption power of those consumers, it generates large organizations. Think about the telcos in China, right? Like as an example, when there is maybe 3 large telcos in the United States, there's one per province in China, right? Like there's a lot more there, and every one of them is huge. So dealing with those volumes of data is absolutely a challenge. Some of the, of course, consumer industries have been taking off differently because of the relatively late adoption in Asia, like and mobile telephony is, of course, a good example of that, where there was no existing infrastructure of landline. So like naturally it would take off much quicker, but like you see some of those trends, they take off and they grow so much faster than they grow anywhere else in the world. And that is just an important challenge to deal with. And then the other side of it, I totally agree with Jeff from a channel perspective, and how can you make your customers in these diverse cultures successful? You need a strong partner network, and that's absolutely key to being successful in Asia. But then on top of that, from a pure technical perspective, and Andrew mentioned this in the context of languages and machine learning, but I look at it even more deeper than technical, is simply character set encoding, right? Like the different flavors of technologies that are out there with all sorts of different implementations of how to store Japanese characters into their database, and then how to pull that out. And of course, in Snowflake, it's all UTF-8, but like, how do you pull that out in a way that it actually, that you know that the data is the correct representation of the source, and you have valid data? That is, like, as simple as it sounds, that's actually a difficult problem to solve, and we're in the midst of that problem oftentimes. And that is I'd say a third big challenge to be successful in Asia. So to summarize it, it's volumes, it's partner network, and then it's the character set encoding on beyond the language, arguably more in the deeper down in the technology. Those are big challenges.
I think with the evidence of like deep learning, all the fancy AI models, everyone thinks that all this magically will disappear. But in the end, encoding is the most fundamental thing. It will trip up any NLP model that you get the encoding wrong, you're dealing with Japanese, Chinese characters, and everything is messed up. And your beautiful, complex neural networks is completely useless if the baseline data is all messed up and wrong. So that's great. I think we are right on cue. So now we are moving towards the Q&A section. We have a few questions posted by the community. So I'll try to go through them and try to tie back to, I think, what the panelists have shared. Let me try this answer live. Do we see a question? Oh, okay. Let me just talk about it. Okay, I think this is related to what Andrew has been sharing about how we can democratize data science, right? So the question here is, what is the collaboration model between data science and business analysts? Usually they are not in the same department. I think to go a bit further is also their roles are also quite different, right? Between data science and analysts. I think Andrew, you mentioned some of the tools, the cloud tools that can make the collaboration easier. Maybe you want to re-emphasize that so that people can understand how will this work with our modern cloud tools?
Yeah, no, it's a great question. And I think obviously there's the human element that no technology is going to fix as far as how to get different groups to work together. We like to think that we can. But when we look at it from the technology standpoint of how do we help this collaboration, it really comes down to, if you're a data scientist and you build a new model for the business and you want to allow a business analyst to use it, across our analytics and AI platform, you can now import that model into our data warehouse, into BigQuery. From there, the analyst could use SQL to be able to actually run inference with your model without ever having to leave a SQL interface or whatever they're using. So it really becomes a tooling of how do we enable the analyst to have access to the powers of an AI platform without really having to worry about what does it mean to build the algorithm, right? So that integration happens from how do we allow you to do your work as a data scientist and make the results of your modeling immediately available to other parts of the business. And then even if they wanted to say that, okay, it's a business person that understands using notebooks, how do you have that integrated experience? So it really is that platform and integrated to say, I could go from a SQL interface, or it's a business user that doesn't know SQL and they're just going to use a spreadsheet. So inside of Google Sheets, they could actually access these same type of results and the models that you're using. So for us, that collaboration is really, as I think everyone's talked about, that skills gap, if you will, between the number of data scientists that exist in the world compared to the number of business analysts that exist in the world. And how do you provide the right tooling? So for us, when we look across it, I think that really comes down to that blending and that fully integration of an AI platform with it. So it comes from using our AI platform, Vertex, integrating those models into BigQuery, making those models now available from a SQL interface. So that happens by just providing the technology to make that seamless for you. Seamless for you to deploy, seamless for a business user to use.
Yeah, I think that's great. They're really empowering the users and that seamlessness, right? You mentioned that keyword to really connect people and ideas and technology all in one place. I think that's really good. All right, there's a question specific on Snowflake. Okay, how do I do real-time aggregation of data before final aggregated data land into Snowflake? I'm trying to understand it clear. Jeff, do you understand the question? How do I?
What I might do is reframe it a little bit. So
Yeah.
basically, I think the important thing to note about Snowflake is that there's a variety of ways of getting data into our platform. As Mark mentioned, we can do micro batching. We can actually support streaming of data into our solution using some of our serverless solutions, and we can read off a Kafka topic. But I think the important thing to note is once the data is into Snowflake, you can actually do a lot of the transformations and aggregations within our platform itself. So hopefully that answered the question. There's a variety of ways of getting data into Snowflake. You don't necessarily need to transform it or to aggregate it before you put it into Snowflake. You can put it directly in. And once it's in our platform, then you can start to subsequently transform it.
Sounds good. Okay, I'll try to group up some of the following questions about latency, about volume and consistency. I think that's a typical question people ask, right? What's your latency? What's your volume? And what's your consistency? Maybe let's start with Mark. So from your perspective, what's a typical latency, and what is large to you? What's a large volume you've seen for real time? What's the largest maybe in terms of volume, and how you maintain consistency? I think that's a pretty good question about throughout the whole system.
Yeah, so so latency varies, right? Like we mentioned before, it's really up to the business to decide what is reasonable latency. We do in the real-time replication space in general see latency go down to single-digit seconds, and those are use cases where, for example, organizations replicate data out of a transactional system, maybe on-prem, into a Google Cloud SQL, and we have customers doing that where these kinds of use cases are there, and again, single-digit second latency is absolutely normal in those kind of scenarios. But then in the case of more analytical use cases like a Snowflake, it's normal to see a minute or even several minutes of latency as the expectation for latency is. That's what the business requires, but it's also from a technology perspective, the more of the expectation for the sole reason that there are these large volumes of data out there. Now, I mentioned large volumes. I mentioned earlier that there's organizations out there now generating a terabyte of changes on a single database in a day. We have customers who run into double-digit terabytes of data, change data on a single database in a day. And those organizations, like, they don't take just one source into a Snowflake. No, they take multiple sources. So you can only imagine that those volumes get quite extreme. And of course, while the total volume of change data isn't necessarily the net amount of change data that the organization needs out of this database, it's still a very significant amount of data that needs to get processed, that needs to get parsed in order to get the data correctly into the destination system. And then you touch upon the challenge around the consistency of the data. Of course, we're all familiar with the traditional relational databases, and there's like 5 decades, if not more, of incremental investments into those technologies. It's very mature. It's almost like it's almost like a service, right? Like, we assume all these features, all these capabilities, because it's so mature, we're also used to it. But one of the aspects of it is transactional consistency. If I have an operation, let's say we're processing orders, and an order consists of multiple, let's say, items in the order, we're processing an order that consists of multiple items, and there's never any items without the order record, nor are there orders that don't have any items, right? Like that might be a business rule that's built into the application, and the database simply enforces that consistency, and through the means of transactions, it keeps track of making sure that when somebody else is looking at the data set, they either see the complete set of the order with its items, or they don't see the order at all, nor do they see any of the items. And that consistency is kind of taken for granted in the traditional database world. Now, we take that model because we process the data using log-based change data capture. The technology is fully aware of the individual transactions, and as we take that data into a Snowflake, and even throughout our micro batches, we still process the data as a transaction. It's obviously a much larger transaction than it would have been on the source in a transaction processing system, but we still process the whole lot as a transaction in a way that with Snowflake's consistency model, we still always will present a consistent view of the data to the end user. And that is, in some organizations, and certainly in the financial industry, and like we're working with, like, let's say, loan processors as an example, like for them, it's absolutely key that they show consistent data, right? Like you want to make sure that employees see how much loan got paid, and likewise, organizations want to be sure about their loan payments, and when the employees have been paid, the money is gone, and likewise, the money can't be lost in transition either. So to get all these things right, like from a log-based change data capture perspective, even into an analytical system, we still get that right because we know the boundaries of the transaction, and we bundle those transactions in a way that once it gets applied to the destination, it's still fully consistent over there as well.
Yeah, I think definitely in the finance realm, like you mentioned loans or even like trading, things that change constantly, right? People will kind of expect it. Like, I want the latest price, I want the latest volume, I want the latest numbers. And you really don't want to kind of like, oh, it's like eventually consistent. Maybe it's like 5 minutes delay, 10 minutes delay. It really depends on use case, and people can get very upset showing them the wrong numbers or the mess up numbers, or like some things fail. It's difficult definitely in real time to manage consistency. I think that's a very good question. So let's move on a bit. Jay have this question. I hear that there is a need to install a lightweight agent at the source. Do we need to install an agent on Target, GCP, or Snowflake? Andrew, Jeff, do you know this question?
No.
Lightweight agent.
No need to.
No need to. That's the answer. No need to. Maybe you want to explain lightweight agent. What does it do?
Yeah, so I can take that question. So from the perspective of delivering the data, right? So we do perform some computations in order to get the data applied to Snowflake correctly. And if there is a micro batch that's going to take place, and we run a single merge statement, we have to come up with a net change per row that went into the data set, right? Like, and it could just happen in a transaction processing system that a row gets inserted, and within the next few seconds, the row gets modified a few times. And every one of these changes are individual transactions, but they end up in a single micro batch going into Snowflake, and we want to apply it with a single merge statement. So we want to have a single view of that row. And to do that, we go through a process, it's called coalescing, is to come up with that net change per row so that we can run that single merge going into Snowflake. And for that, we use, we recommend the use of an agent for scalability, security, and performance reasons. And that's why we like it. Now, it doesn't reside on Snowflake. Snowflake, there is no such concept of knowing where Snowflake runs from a server perspective. The user doesn't have access to that server. It's managed by Snowflake, and we don't worry about it. We connect to the warehouse, and we utilize the warehouse resources, and it spins up. It might spin down again, and like that's all managed by Snowflake. But from the perspective of then getting the data into Snowflake through internal staging on GCS or explicit external staging on Google Cloud Storage, we get that data in and apply it to the destination. That's where the agent comes in.
Sounds Good. So I think that is that. There's another question of Jay. I'll skip that first. With the interest of time, let's try to cover like the two other questions. How do you see the competitive landscape of capturing technology? I don't quite understand capturing technology. Do you guys have a feel of it? Competitive landscape of capturing technology. Are they talking about kind of like
I think that's a Mark question.
Yeah. Go ahead, Jeff.
Yeah, so I think from a capturing technology perspective, so there is certainly there's alternative technologies available from a capture perspective. I think where we see a large differentiation with the HER technology is just this core concept of the distributed setup. Like you'll see some of the competitors, they will recommend more of a centralized setup where there's a remote reach out to the system. And whilst this is like, at least conceptually, it's easier to deploy, at the same time, it doesn't provide for the volumes necessarily that you'd want to achieve. And it opens up challenges with, let's say you run in Google Cloud and you have to remotely reach out to a system that resides on-prem somewhere. There's holes in the firewall that need to get created, highly privileged users that have to be enabled. And it's a security risk when these kinds of operations have to take place. And with the distributed environment and setup, there's all sorts of capabilities and features we can leverage to make that communication more secure. And then there's the compression to make it more efficient. And at the end of the day, simply less load on the source systems, where we talked about before with the large volumes and the 24/7 operations for today's organizations. Is just, you really want to minimize the load on that system to keep the primary operations of the organization going.
Gotcha. I think we have 1 more minute, but the last question is about real-time delivery systems, stock trading. Whether real-time delivery system is very popular with stock trading besides machine learning on doing data delivery. Trying to rephrase it. Can you guys see the question? Like what does this mean? No, Andrew, I'll put you on the spot. Do you have any feel for this?
The first thing that pops to mind is really the dumb terminals that we've had for years, like the Bloomberg terminals, as a data delivery. If it's something other than that, and if the real-time delivery is how do you get it back into a system to do analysis on, then I think it comes down to how are you capturing that data and ingesting it. All right, so if you are getting it from, I don't know, let's just say it's a Forex market and a Forex stream of data, then you need some way of capturing that. And we see that being, definitely, I think, popular. If customers want to ingest real-time streams of transaction data, they may not run machine learning on it to make decisions in flight of that data, but stream it in so they could do further processing of it. Maybe you want to be streaming in all these transactions so you could combine it with information about a customer to then be able to do things to understand, Jeff's a high value customer to us. If he calls in based upon his transactions and other customer history, and he calls into our call system, I want to route him to a live agent. So I can see the data delivery being used if you're delivering it to another system and not making a machine learning decision on the fly, then yeah, and whether that's getting streamed in and going to Snowflakes, streamed in and going to our infrastructure and our warehousing technology, or streamed into any partner's technology, it certainly could be a thing of opening up that fire hose and bringing data in. But then it ends up with, yes, we could do all these things at scale, and yes, we have this kind of bottomless pit, if you will, of like infrastructure and capabilities, but you have to start with the why. All right, of why do you want that stream of data? Is there a question you're going to answer? So I think I'd flip it, but there absolutely is a need for it. It is popular. Real time is out of the playpen, if you will, no longer an experiment, and neither is AI. So I think you need to start with the business question in mind. What do you want to do with that? Is it delivered to Snowflake so you could run analysis and make some interesting discoveries with it? Is it delivered to our technology, delivered to somebody else? What are you doing with that data?
Yeah, I think, Andrew, you're right. It always comes back down to the business question, like what do you want to do with it? And then we could go from there to solve the problems. I think that really closed off our entire topic for today. I think I'd like to, we are slightly 2 minutes over, but I really want to thank all our panelists. Thank you so much for sharing all your insights today. And really thank you everyone for joining us in our call today. So yeah, I think that's a wrap for our event. And yeah, I see you guys maybe in future events. Thank you so much, everybody. Take care.
Thank you.
Bye.
Thank you.